Well, dear students, in last video I told you beats, phenomena of beats, and I told you that beats are produced by two sound waves having a slight difference between their frequencies. And this is my experience. It is difficult for me to make the student learn what is beat frequency. Beat frequency. I had to work hard to make a student learn that what is beat frequency. The beat frequency is equal to difference of frequency of two sound waves. I told you also that two sound waves should have a slight difference in frequency. Why it is there? Why they should not have large difference? Actually, persistence of sound or any other effect like visibility on eye is 1 by 10 seconds. Any sound which we listen persists on our ear for a time of 0.1 second, 1 by 10 second. If any other sound comes within this interval of 1 by 10 second, then we are not able to differentiate between two sounds. Time of persistence of any effect on our nervous system. Actually, when we see anything and then next thing, if difference between the two happening is more than 1 by 10 seconds, then we can distinguish that two different events have taken place, whether it is picture or sound. So I have told that beats are produced by two waves having slight difference in frequency. If there is a difference of 20 Hz, then beat frequency 20 Hz. So it means time interval will be less than 1 by 10 seconds. So we will not be able to distinguish between two loud sounds or two low sounds. We will actually low sound we don't listen, but so it will remain loud sound on our eye. So beats cannot be observed. We observe only that. So this was the fact. 1 by 10 seconds. If the time interval between two events should be more than 1 by 10 seconds. Only then you can listen two sounds separately. We listen echo. If time interval between the sound sent and echo is less than 1 by 10 seconds, then we don't listen echo. If it is more than 1 by 10 seconds, we get the sound and we listen the reflected sound. Echoes are nothing, these are reflected sound. Now application of beats. First application is there, musicians make their music more melodious by having a slight difference between the frequencies of two similar organs. Organ means like dholak, harmonium, the instruments which are used to produce sound. Remember, sound is produced by vibration, and every vibration has its own characteristic frequency. For example, if we have two star wire of same length, so slight difference in length will have. I will tell you what the frequency formula for star wire. So n equal to 1 by 2l under root t by l. Either you change tension or you change length. If two wires are under same tension, then by having a slight difference in frequency, we can change the frequency like that. So musicians make their music more melodious by having a slight difference between the frequency of two similar organs. Second application for scientific purpose, to determine an unknown frequency. I have felt that students feel lot of difficulty here. In laboratory, you may have seen tuning fork made of steel or any other alloy also. You say, I will tell you later on how this is achieved. This is the stem and these are called fork. The frequency of tuning fork is in directly proportional to the elasticity. There is no particular formula. Inversely proportional to mass per unit length. Lesser the mass per unit length, higher the frequency. So if we have two tuning fork of nearly same size, and suppose it is A and B, and we are giving frequency of A known to us, suppose this frequency NA is equal to 200 hertz. 200 hertz. It makes 200 vibration per second. The frequency of P is not known. So we can, but they should be very close in shape and size. Mass and length and the material of the two should be the same. So when we make it vibrate, fork oscillate like this and stem like this. Transfer vibrations are produced in stem vibration and longitudinal in stem. So we make them produce sound together. We strike them on rubber band and put somewhere. Then they are vibrating together, and suppose we get 5 beats per second. Suppose we get 5 beats per second on sounding these tuning fork A and B together. What it mean? I told you beat frequency is equal to difference of frequency of two sources. So since beats frequency is equal to difference of frequency of two sources. So possible frequency has possible frequency of B of tuning fork B is equal to 200 plus minus 5, that is 215 or 195 or 205. So these are possible frequency of B. So we have determined the possible frequency by listening the beats. Remember, beat frequency is equal to difference of frequencies of two sources. I told you that frequency of tuning fork inversely proportional to mass per unit length. So there are two methods to change the mass of tuning fork. One by filing. If we file this, we rub by sandpaper, then some mass will be scratched and mass length will decrease. On decreasing mass length, frequency will increase. Second method, we load any tuning fork with some wax, so that way mass length will increase and hence frequency will decrease. Suppose here we load tuning fork B. We load, suppose we load tuning fork B with a small mass of wax and make the tuning fork, two tuning fork. To produce sound together. We, after putting some wax on this, we make or we sound the two tuning fork together. And suppose we get now 3 beats per second. Suppose we get 3 beats per second. It means difference between frequency of A and B, difference between frequency of A and B 3 only. This 200 frequency of A remain 200. Our possible frequency are 215, 205 and 195. Possible. So when we increase mass, this frequency decreases and difference remain only 3. This 200 does not change. If we assume 195, so it decreases further, the difference will increase. So beat frequencies should have increased, but it has decreased 3 beats. We get 3 beats. It means difference between this and this is 3 only, and it will be possibly if it decreases from 200 to 5 to 3. And therefore, frequency of B, actual frequency of B, actual frequency of B is equal to 203 Hz. So this way you will get a big number of questions on beats. And in every competitive exam, in every board exam, in class 11 exam, there is certainly question on beats. The teacher has taught you beats. Problem is that schools decide, the school teacher decides syllabus themselves, which is very bad. This is my experience. I have seen some students are telling us that, sir, we are still on thermodynamics. So when they will finish it is January, and in February there will be exam. Now I gave you one more question here, so that you may understand beats. Question है two sound waves of wavelength 1 meter and 1.01 meter when travel through a gas through a gas they produce 4 beats per second. What is the two sound waves of wavelength 1 meter and 1.01 meter when travel through a gas they produce 4 beats per second? What is the speed of sound waves through the gas? जिस गैस से वो पास हो रही है वेव, उस गैस में उनकी स्पीड क्या होगी? What is the speed of the waves in the gas? Actually, learner always feel lot of difficulty. One year I was in lab for practical exam. I conducted practical exam for class 11. In our school we had 5 sections that time, and each section was having more than 40 students. I asked simple question. These are supposed to waves of wavelength 1 meter and 1.01 meter. So which wave will be traveling faster? दो साउंड वेव हैं, उनका वेवलेंथ 1 मीटर और 1.01 मीटर, तो कौन सी वेव की स्पीड ज़्यादा होगी? ये मेरा क्वेश्चन था क्लास 11 के प्रैक्टिकल में. द एग्जाम टू प्लेस फॉर कंटिन्यूअस 3 days and it was my bad luck. I say it was my bad luck that no one could answer this question. Please don't be so lazy. Don't be so careless. Nowadays students are carefully careless. दुख होता है मुझे कहते हुए. I keep on telling कि speed of sound wave is the characteristic property of medium, not that of frequency. All sound waves, whether audible sound, infrasonic sound or ultrasonic sound, are there. If they are traveling through same medium, they will have same speed. Okay, problem is that V equal to L lambda is there. Actually, this equation confuses. V equal to L lambda. Yes, this is a relation. But the speed of wave, sound wave, is not characteristic of frequency or wavelength. The speed of wave is the characteristic property of medium. Then how to find here? Well, let the speed of wave be V. So what the frequency from this formula? Frequency N1 V upon 1.0 meter 3 hertz, N2 V upon 1.01 meter. So naturally this is less than this, because the two sound waves produce 4 beats per second. So therefore N1 minus N2 is equal to 4. means 4 equal to b bracket 1 upon 1 minus 1.01 meter. Yesterday I gave this question to student who comes to me offline. They were not able to solve this. I don't understand what is the problem with the students. Why they ask? So LCM I take 1.01. It is 1.01, it is 1. So what is left here? 4 is equal to b into 0.01 upon 1.01, which is b upon 101. Simply, don't scratch the decimal. We understand like this. Or b equal to 4 into 101, यानी कि 404 meter per second was the speed of two waves through that gas. This is a model question, dear student. I just wanted to tell you that beat frequency is equal to difference of frequency of two sources, and in this question the message there that speed of sound waves does not depend on frequency or wavelength, depend on elasticity and density. I have told you so many formulae. Please adhere to what I say, listen to me carefully. The chapter of wave is not, I will tell you many things coming ahead, what the people keep on teaching. One of my students was very clear when he went to a B.Tech class, physics was being taught, and teacher told that wave travel like this. Wave always travel straight. There are many misunderstandings in this chapter. So please like the video, share the video, and please ask your friend to subscribe my channel. Thank you.